Good evening. Before we start solving sums, let us revise tangency in case of circle. So the first point in case of tangency is equation of tangent to circle at a point x1 y1 on it. If we consider standard circle x square plus y square equal to a square, what is the equation of tangent? It is xx1 plus yy1 equal to a square. And tangent drawn at p of theta will be what? X cos theta plus y sin theta equal to a. Now equation of tangent to general circle at x1 y1 will be what? Xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Second part is to find the condition that line y equal to mx plus c may be tangent. Here we consider only standard circle, that is x square plus y square equal to a square. So what is that condition? C equal to plus minus a into root 1 plus m square. This means there are two tangents which can be drawn to the standard circle having slope m. Of course, they will be parallel to each other. And what is the point of contact? Minus a square m upon c, a square upon c. So what will be the equations of tangents then? Y equal to mx plus minus a into root 1 plus m square. Now just remember this point of contact, because if you consider c is plus a into, put that value of c. If you consider c equal to minus a into, put that value. Is that clear? Third part. In general, two tangents can be drawn to standard circle from a point x1, y1 in the same plane. Their slopes are roots m1, m2 of this quadratic equation. X1 square minus a square m square minus 2x1 y1 m plus y1 square minus a square equal to 0. And the last part, the tangents drawn can be perpendicular to each other. So the locus of points, tangents from which to the standard circle x square plus y square equal to a square are at right angles is again a circle. Its equation is x square plus y square equal to 2a square. It is called as direct circle. Now second miscellaneous exercise 6, second question rather. These sums are for homework. Answers for first and fourth are given. Okay. Actually 7 sum I will upload solution of this, but first you should try. So we'll be solving sum number 2. Second one, find the center and radius of the circle x equal to 3 minus 4 sine, y equal to 2 minus 4 cos. Now to get the equation, basically this represents locus, which is a circle. We are given that, but I will eliminate the parameter. Okay, so rearrange the terms. X minus 3 by minus 4 is sine theta, y minus 2 by minus 4 is cos theta. Square and add. Rearrange the terms to get x minus 3 square plus y minus 2 square equal to 16. Now this is comparable with center radius form, x minus h square plus y minus k square equal to r square. So the center hk is 3, 2. And what is radius? Root 16, that is 4. Now let me explain the solution. Don't write this. Find the equation of circle passing through the point of intersection of lines x plus 3y equal to 0 and 2x minus 7y equal to 0, whose center is the point of intersection of the lines x plus y plus 1 equal to 0 and x minus 2y plus 4 equal to 0. This is not difficult. Yes, this is lengthy because we have to solve these two equations to get point on the circle and these two equations to get the center. Then find distance between them to get the radius. Let PHK be the center of the circle, which is point of intersection of these lines. Solve to get center as minus 2, 1. Now circle passes through the point of intersection of these points. Clearly, origin is the point of intersection of these two lines. Both lines pass through origin. So what is radius? It is OP, that is root 5. So by center radius form, what is the equation of circle? X plus 2 square plus y minus 1 square equal to root 5 square. that is x square plus y square plus 4x minus 2y equal to 0. Actually, we have solved one sum of this type, but still we'll discuss this. The line 2x minus y plus 6 equal to 0 meets the circle at A and B. Find the equation of circle on AB as diameter. Now this is the equation of circle and this is equation of line. Let A x1 y1 and B x2 y2 be the points of intersection of circle and line. To find the points of intersection, we have to solve 1 and 2. From 2, what is y? 2x plus 6. Put this in 1. To get these values of x, minus 5 minus 9 by 5. Take x1 as minus 5. So for this value, what is y1? Y1 is this one, minus 4. And for x2 equal to minus 9 by 5, what is y2? 12 by 5. So A is minus 5 minus 4 and B is minus 9 by 5, 12 by 5. These are the extremities of diameter. So use diameter form to get equation of circle. What is that diameter form? X minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. On simplification, you get this equation as the final answer. Sum number 8. Find the equation of tangent to the circle x square plus y square equal to 64 at the point P 2 pi by 3. So what is equation of tangent to x square plus y square equal to a square at P of theta on it? X cos theta plus y sin theta equal to a. For the circle x square plus y square equal to 64, what is a? 8. Theta is given to be 2 pi by 3. You may convert this into degree also, 120 degrees. Now what is sine 120? 120 is supplement of 60. So 120 is 180 minus 60. Sine of 180 minus theta is sine theta. Allied angles. So it is root 3 by 2. What is cos 120? It is cos of 180 minus 60. Somebody is asking why not 180 minus 120? See, is 120 180 minus 120? No, 120 degree is 180 minus 60. That is why what is cos of 180 minus theta? Minus cos theta. Minus cos 60 degree is minus half. Substitute the values. So what is the equation of tangent? X into minus half plus y into root 3 by 2 equal to 8. Multiply by minus 2 to get x minus root 3y plus 16 equal to 0. We'll just discuss this. Ninth one. Find the equation of locus of point of intersection of perpendicular tangents drawn to the circle. Basically, equation of circle is given in parametric form. You have to obtain that in Cartesian form. So eliminate theta. So this circle is simply x square plus y square equal to 25. Okay. How to get this? On squaring and adding. Let P x1 y1 be a point on the required locus and m be the slope of tangent drawn from the point P to the circle. We have already done this. The equations of tangents are y equal to mx plus minus a into root 1 plus m square. But a is phi here. Okay. So y equal to mx plus minus phi into root 1 plus m square. Now tangents pass through which point? X1, Y1. Why? Because from that point only they are drawn. So this has to lie on the tangent. Right? If we say no, then we are lying. Okay. So y1 equal to mx1 plus minus phi into root 1 plus m square. Rearrange the terms. Actually, this is the proof of third part in case of tangency. So you may ask me, sir, can we use the final result directly? If asked for 4 marks, you cannot use the result directly. You have to use this method only. But if asked for 2 marks, yes, you can use this result directly. Do you remember this? In the beginning only I explained this. X1 square minus a square, where a square is square of the radius, m square, minus 2x1 y1 m plus y1 square minus a square equal to 0. But here it is obtained. rearrange the term square, get a quadratic equation. Why to get a quadratic equation? Because the roots m1, m2 are the slopes of two tangents which can be drawn. See, the roots m1, m2 of this quadratic equation are the slopes of the tangents that can be drawn to the circle from the point P. Okay. Now, m1, m2 is this constant upon coefficient of m square. Now, these are perpendicular. That is the requirement. So, product of slopes is -1. Rearrange the terms. To get the equation of locus, we replace x1 by x and y1 by y. So, the locus is x square plus y square equal to 50, which is again a circle. Good student will write that this is called as direct circle. If asked as MCQ, we will be able to write answer directly. Why? Because direct circle of x square plus y square equal to a square is x square plus y square equal to 2a square. So 2 into 25, that is x square plus y square equal to 50. But this will be asked for I think 4 marks. So you are expected to write this much. Okay. Sum number 10. Find the equation of the circle concentric with x square plus y square minus 4x plus 6y equal to 1 and having radius 4 unit. What do you mean by concentric? Concentric means having the same center. So we must obtain center of the given circle. It is 2 minus 3. Same is the center of the required circle. The radius of required circle is given to be 4. So use center radius form to get the equation of circle as x minus 2 square plus y plus 3 square equal to 4 square. On simplification, it is x square plus y square minus 4x plus 6y minus 3 equal to 0. Sum number 11. Find the lengths of the intercepts made on the coordinate axis by the circle. We'll be doing part 1, first sum, second for homework. See, what do you mean by intercept made on x-axis? For that, we have to find points of intersection of x-axis and the circle. So, maximum, in fact, this is not tangent. X-axis is not tangent to the circle. So, circle cuts x-axis in 2 points. What is the speciality of those 2 points? Y coordinate is 0. So, put y equal to 0 in the equation of circle to get this. So x equal to 10, x equal to -2. This means circle cuts x-axis in which points? A 10, 0, B -2, 0. So what is the length of intercept on x-axis? AB. Actually, there is no need to use distance formula. You can say it is mod of x1 minus x2 or use that also, distance formula, to get 12 units as the length of intercept on x-axis. Actually, this is not required in exam, but if possible, try to draw the rough sketch. Of course, it is not up to the scale, but still, yes. Okay. Second is for homework. Answers 9 and 15. Let us discuss this common tangents. First case rather, if C1, C2 are the centers and R1, R2 are the radii of two circles, then these circles touch each other externally if distance between centers, that is distance C1, C2 is R1 plus R2 and the point of contact P divides join of two centers, that is C1, C2 internally, in which ratio? R1 is to R2. Now number of common tangents will be 3. Why? Let me explain. See, this is the first, observe the cursor. This is the first common tangent. This is the second common tangent. And this is the third common tangent. Okay. This is interesting. Second, if C1, C2 are the centers and R1 and R2 are the radii of two circles, then these circles touch each other internally if distance between two centers is mod of R1 minus R2. Why modulus? Because we do not know which is greater, but distance is always positive. And the point of contact divides C1, C2 externally, in which ratio? R1 is to R2. Note that only one common tangent at P can be drawn. Third case, this is interesting. Two circles with centers C1 and C2 and radii R1, R2 neither intersect nor touch each other if distance between centers, that is distance C1, C2 is greater than R1 plus R2. In this case, four common tangents can be drawn. See, this is first, this is second, this is third, and this is fourth. Is that clear? Yes, this part is important and interesting. Don't write this. I have uploaded this file on the first day only. Now this type is important. Show that the circles touch each other externally. We have just discussed this in fact. Find their point of contact and the equation of their common tangent. First one. Now for the first circle, find center and radius, that is C1 and R1. For the second circle also, find center and radius. Find distance between two centers. It comes out to be 10. Use distance formula. Now for touching circles, either R1 minus R2 is 10 or R1 plus R2 is 10. Here 7 plus 3 is 10. So circles touch each other externally. Now point of contact, see we are asked to find equation of tangent, common tangent, right? So we must obtain coordinates of that point of contact. It divides C1, C2 internally in which ratio? R1 is to R2, that is 3 is to 7. So apply section formula to get point of contact as 1 by 5 minus 13 by 5. Now consider any one of the two circles. We know equation of tangent to general circle at x1, y1. Use that form. Actually, C2 is minus 4, 3, R2 is 7. But initially, I had written root of 16 plus 9 plus 25. Make that correction. It should be root of 16 plus 9 plus 24. That is root 49, which is 7. Now to get the equation of tangent, you can consider any one of the two circles because it is common tangent. So if I consider this equation, then it is x1 plus y1. x1, y1 is this. Now 2g is minus 4. So g is minus 2. So minus 2 into x plus x1. So x plus 1 by 5. 2f is 10. So f is 5. Y plus y1. y1 is minus 13 by 5. Plus c equal to 0. Tell me, on simplification, we get what? You have to write all the steps, but final answer should be 3x minus 4y minus 11 equal to 0. So this is common tangent. Just check the answer. Actually, second is for homework. Common point is 1, 2 and this is common tangent. Now sum number 13. Show that the circles touch each other internally, find their point of contact and the equation of their common tangent. For the first circle, center is 2, 2, radius is 6, R1. For the second circle, center C2 is 2, 0, radius R2 is 4. By distance formula, C1, C2 is 2, but it is nothing but R1 minus R2. So circles touch each other internally. Suppose P is point of contact, right? Then it divides join of C1, C2 externally. In which ratio? R1 is to R2. So by section formula, we first get that common point P, then use any one of the two circles to get the equation of common tangent. So what is that point P? 2 minus 4. So common tangent. For that you can consider any of the two circles. I have considered second circle because it does not contain a term in y. So x1 plus y1. x1 y1 is 2 minus 4. Now 2g is minus 4. So g is minus 2. So minus 2 into x plus x1. There is no term in y. Constant term is minus 12. So equate that with 0. Simplify to get common tangent as what? Y plus 4 equal to 0. Second sum is similar. It is for homework. This is the common point and this is the common tangent. So That's it for today.